Hi, in this video we are going to practice balancing chemical equations. Let's get started. Let's start with this simple synthesis reaction of magnesium reacting with oxygen gas to produce magnesium oxide. To balance chemical equations, what you need to do is you need to have the number of atoms on the left side of the equation, our reactant side, to be the same as the number of atoms on the product side or the right hand side of the equation. And the way we're going to do that is by introducing coefficients or whole numbers in front of each product and each reactant. So for this example, we have one magnesium atom on both sides of the equation, so no problem there, we're balanced. And on the left hand side we have two oxygen atoms, on the right hand side we have one. So in order to balance the oxygen, we need to introduce a coefficient of 2 in front of the magnesium oxide. So now, instead of us having one magnesium and one oxygen, we now have two magnesium and two oxygen. So we've balanced the oxygen. Now the magnesium is not balanced. So to balance it, we just introduce a coefficient of 2 in front of the magnesium on the left hand side of the arrow. Now we're balanced, but let's check to make sure our work is correct. We have 2 magnesium on the left, 2 on the right. We have 2 oxygen on the left and 2 oxygen on the right. We're balanced. Moving on to our next problem. We have water, or H2O, breaks down into hydrogen gas and oxygen. On the left hand side we have 2 hydrogen atoms, and on the right we have 2 hydrogen. Perfect, those are balanced. On the left hand side we have 1 oxygen, and on the right we have 2 oxygen. So we need to balance the oxygen. If we introduce a 2 as our coefficient in front of the water, we end up having 4 hydrogen and 2 oxygen. So now we've balanced the oxygen, so we then need to go ahead and balance the hydrogen by placing a 2 as a coefficient in front of the hydrogen on the right hand side. If you don't see a subscript or a small number by the elemental symbol, then you can assume it's a 1. If you don't see a number in front of the elemental symbol, you can assume that the coefficient is 1. Alrighty, let's try some harder problems now. We have copper reacting with silver nitrate to produce copper nitrate and silver. Go ahead and pause this video and try to solve it on your own. Alright, hopefully you attempted the problem by yourself. Let's do it together. We have 1 copper on the left and 1 on the right. We have 1 silver on the left and 1 silver on the right. And as for the nitrate, the NO3, it's easier to treat it as a unit because it makes balancing the equation much easier. So on the left hand side we have 1 nitrate And on the right hand side, we have 2 of the nitrate. So what we need to balance here is the nitrate. Least common multiple of 1 and 2 is 2. So we need to introduce a coefficient of 2 in front of the silver nitrate on the left hand side. So now we have 2 silver and we have 2 nitrate on the left hand side. The coppers are still balanced, there's no issues there. The nitrates are now balanced. We have 2 on the left, 2 on the right, but the silver is not balanced, so we need to balance the silver. Again, least common multiple of 2 and 1 is 2, so we need a coefficient of 2 in front of the silver on the right hand side. So let's just check our work. We have 1 copper on the left, 1 copper on the right, 2 silver on the left, 2 silver on the right, and we have 2 of the nitrates on the left and 2 nitrates on the right. We have mercury nitrate, react with ammonium sulfide, to produce mercury sulfide and ammonium nitrate. Alrighty, so on the left hand side we have 1 mercury atom, on the right we have 1 mercury atom. For the nitrate, again, treat that as a unit rather than individually treating it as nitrogen and oxygen, because it makes balancing the equation simpler. On the left hand side we have 2 nitrates, and then on the right hand side we have 1 nitrate group. Moving on to the ammonium, again, treat that as a whole, as a unit, instead of treating it separately as nitrogen and hydrogen. So NH4, we have 2 ammonium groups on the left, and then we have 1 ammonium group on the right hand side. And then as for the sulfur, we have 1 on the left and 1 on the right. So we need to balance the nitrate and the ammonium group. Let's start off with the nitrate. So we have 2 on the left and we have 1 on the right. Least common multiple of 2 and 1 is 2. So let's introduce a coefficient of 2. So now we have 2 ammonium groups on the right and then 2 nitrate groups on the right. So now our equation is balanced. Here we have butane reacts with oxygen gas to produce carbon dioxide and water. It looks pretty daunting, but it's doable. On the right hand side we have 1 carbon and we have a total of 3 oxygen, but let's break it up to make it easier to balance. So we have 2 oxygen as part of carbon dioxide, followed by 1 oxygen as part of water, to get us a total of 3 oxygen on the right hand side. And as for the hydrogen, we have 2 hydrogen on the right. On the left we have 1, 2, 3, 4 carbon, and we have a total of 2 oxygen on the left, and as for the hydrogen, we have 2 plus 3. We have 3 plus 2 plus 2 plus 3. That gives us a total of 10. Let's start by trying to balance out the carbons first. So on the left we have 4, and then on the right we have 1. Least common multiple of 1 and 4 is 4. So let's make the coefficient in front of carbon dioxide to be 4. With a coefficient of 4, we have 4 carbon on the right and 8 carbon and 8 oxygen as part of carbon dioxide on the right hand side. So total, now instead of having 3 oxygen, we have a total of 9 oxygen on the right. So we've balanced the carbons. It's left with the oxygen and the hydrogen to balance. Of the two, the hydrogen looks a little bit easier to balance, so let's do that one first. Least common multiple of 10 and 2 is 10, so we need to introduce a coefficient of 5 in front of the water. So now we have 10 hydrogen on the right and 5 oxygen as part of the water. So total we have 13 oxygen on the right. So we've balanced the carbon and we've balanced the hydrogen. Now the issue is the oxygen. For the sake of balancing the equation, we are going to have to multiply the 2 oxygen on the left hand side by 13 over 2. That way we can have 13 on the left and 13 oxygen on the right. However, keep in mind that we cannot have coefficients be fractions. They need to be whole numbers. So although our equation is technically balanced, it can't stay like this for it to be correct. So what we have to do is we need to get rid of this fractional coefficient by multiplying this whole left hand side of the equation by 2. So now we have 2 in front of the butane and 13 in front of the oxygen. So total we have 8 carbons on the left, 20 hydrogen on the left, and now we have 26 oxygen on the left. And it's an equation, so what you do to one side, you have to do to another. Because we multiply the whole left side by 2, we have to do the same to the right hand side. So now instead of a coefficient of 4 in front of the carbon dioxide, we have a coefficient of 8, and then instead of a coefficient of 5, we end up having a coefficient of 10 in front of the water. And so now our equation is balanced.